Welcome to How to Become a Production SQL Database Administrator. My name is Raphael. And continuing with the concept of indexing, we're now going to look at the concept of index fragmentation and index management. We're going to be looking specifically into what is a rebuild of an index and what is a reorganization of an index, and some of the concepts here. But before we do that, let's look at an example here of how you get what's called fragmentation. So I'm going to open this here, and I'm going to open this here. And what I want you to look at, obviously, is this. So I've got a Excel sheet. Now, obviously, this is analogous to a book. So imagine this is page 1 with these 3 words. Then you got the other page with these 3 words. Page 3 has these 3. Page 4, page 5. Now, obviously, we've been talking about indexing and the advantages of having an index. So if I were to ask you to find the word Barker, then obviously what you're going to have to do is you're going to have to go to page 1, and you're going to have to read each individual letter. And if you don't find it here, you're going to go to page 2. And if you don't find it here, you're going to go to page 3, and there it is. So that took you a little more time to find that Barker. And same thing here. So you're going to have to actually continue going to the next page, because there may be another Barker. Even though you've seen one here, you still have to go through the entire book, or these 5 pages, to make sure that you've covered all Barkers. And then you'd have to go to page 5. So now you know you have page 3 and page 4 Barker. Now that was easy, but obviously if this page has thousands of book pages, it's going to be a very tedious thing. But now, what if I took that book and created an index? And obviously now I'm going to create a non-clustered index here. So what I'm going to do is I'm going to, for each word here, I'm going to index it on that specific page. So here I've created a separate page. Now this is a non-clustered index, as you can see, because this is an additional space. I've used an additional page to create an index. And we've been mentioning the concept of disk space, so I hope this illustrates even further. So now if I take all this words on the first page, words on second page, third, fourth, and fifth, and then I index them in terms of where they belong in what pages, then you get this kind of an index, and this alphabetized. So Barker obviously is on page 1. Now obviously this is based on the last name here, and it's alphabetized. But these numbers right here, 1, 4, 3, 5, 2, 5, these are what obviously refer to the index parlance as pointers. It points to the actual page where that specific item is, or this object, in this case, the name. So now if I were to ask you to find Crosby, all you have to do is just go down to Crosby and look at the page 5, and instantly go here, and you've discovered this. So that's a great benefit of indexing, and I think we've gone over that many times. But one thing I want you to understand is that even though you have this indexing, over a course of time, there are going to be operations where you're going to update a table, you're going to delete columns, you're going to delete columns, update columns, and you're also going to drop columns. And so what happens when that occurs? So for example, now in the course of time, obviously, these operations, the insert, update, deletes, causes this to become incompatible with this, or incongruous to this, or I should put it in lesser terms, it becomes disorganized. So for example, if I go to page 3 here, and let's say now I delete this. If I delete this and cult has been deleted, it has to match here. So now this has to be deleted. So if I delete this and the index, because it has to match that, you'll see that there's a gap there. So this is being reorganized here. And let's go for the Dwayne 4. If I go to page 4, and now I've updated Dwayne to Simpson. So let's say I've taken that word, Dwayne, copy, and I've updated this. Obviously that particular index has to account for that, because now that name is Dwayne. It no longer belongs to Dwayne, it becomes Simpson. So as you can see, this continuous modification of the data itself is causing modification to the index itself. And over this course of time, this index becomes disunified or unorganized. And this is what is called index fragmentation. And when you have large amounts of index fragmentation and you have not managed this, it can be a tremendous amount of performance issue. Anytime you have users asking you or telling you, hey, I'm sending a query and I'm pressing OK, and it's taking 2 minutes or 3 minutes to return data, one of the first things you should be looking at is index fragmentation. And this is what we're going to be discussing in the next in this video. So I hope this gives you a very simple way of understanding what happens to an index as you modify data. I'm being very simplistic obviously here, but I want to keep it that simple. So let's close this now. So now that we know what index fragmentation is, let's look at some of the concept. So when index fragmentation occurs, should you reorganize the index or rebuild? That's the question you have to decide. And obviously it depends. And it depends on several factors. The factors that we're going to be looking at is this system function. This is a system function that when you execute, it allows you to detect and discover fragmentation of the index. And we base the decision whether to reorganize or rebuild based on this little formula here. So when we execute this, which I'll do in a second when we go to SQL, and if we discover that the average fragmentation percent value in the column is greater than 5% or and less than 30%, then we have the option of reorganizing rather than rebuild. If we find that the average fragmentation in percent value is greater than 30%, then we have to rebuild the index. So what does reorganize and rebuild an index mean? Well, let's look at it here. So remember what fragmentation is. So that's why I've highlighted it here. Fragmentation exists when the index pages in the logical order does not match the physical ordering inside the data file. And I think I just demonstrated that to you very simply. So again, should you rebuild or reorganize? Well, let's look at the difference. When you rebuild an index, SQL drops the entire index and removes the fragmentation, obviously, reclaims the space by compacting all the pages and reordering them in a contiguous form. So basically, it throws away the index that you have and rebuilds it from scratch, and then it reorganizes it in the base in the value that you have determined by the index. If you reorganize an index and it's less than it's here, this percentage, then when you reorganize an index, it basically goes to what's called the leaf level of the cluster of the indexes and just physically sorts them. I don't want to get into the too detail of what leaf level is in B trees because I think it'll get a little too complicated. I want to make it as simple as possible, and as we get more advanced, then we'll talk about B structures and other structures. But it suffice to say that depending on the outcome of your query, if it's between these two values, then the decision has been made to reorganize. If the decision is greater than 30, then you know you have to rebuild it. And obviously, you can have jobs running to either dependent upon this value here. Just a couple other notes is that when you're rebuilding an index, it can be executed online or offline. So you can do this offline. And if you're reorganizing an index, it can only be executed online. You can't do it offline. So just a couple of notes there. Now, when you decide what to do and when you have a job and executing a rebuild or a reorganize, make sure you do this off hours. Make sure you plan the job to be executed off hours. This is a resource intense process. So now that we know a little things, let's actually move to SQL. And I'm going to show you an example of how we get fragmented data. And then we'll look at the result value of the average percent fragmentation and decide what to do. Now, if you notice here, we've already used this kind of an example before, so I'm going to use it again. Here, I don't have a database called shrink database. I'm using this from the previous course, but this is fine. So basically, I'm just going to create a database. Now, I'm going to go pretty fast here because I'm just creating a table. I'm going to insert some data. I'm going to look at that data. Or actually, it's still inserted. There we go. Let's look at that data. And now I want to look at the size. using the SP help database of that database. And as you can see, it's about the same size. It's a little larger. Now I'm going to create a second table. Well, let me, create a second table, which is right here. Now, obviously, all this is provided for you. And I'm going to create now a clustered index on that second table. Now, the whole notion about this, I've discovered this in the previous video, and this was to look at how shrinking a database is detrimental to clustering, but I think for our purposes is fine. So that's why I'm kind of breezing over this, but I've already illustrated that. The whole point of this illustration here is just to show is what happens when you get fragmented data. And one of the key things that allows you to have fragmented data is shrinking a database. And we've discussed that as to why we should not shrink a database. So let's go. So now that we've done all this, now what I'm going to do is I'm going to use that function, and there's the function. So again, I'm going to provide you with this function, so you don't need to do it. The only thing I've done is make sure you change the database name here and the object ID, in this case, the table name second. So when you execute this particular function determines the percent of fragmentation. So I'm going to execute this, and you'll see that the fragmentation is virtually 0 at this point. So that's a good thing. So now what we're going to do is I'm just going to drop this table. Look at the shrink size, the database size. And now what I'm going to do is actually I'm going to shrink the database. Now, shrinking the database, when you shrink the database, it rearranges all the index pages in an organized fashion. So back to this, what I'm doing now is I'm saying, hey, I've done so many deletes, I've done so many updates, so many updates and so on, and this has become disorganized, and it's not matching the data because of the constant deletions and updates and so on. So what I'm going to do basically now is I'm saying, hey, I'm going to shrink the database, and this is going to cause a massive defragmentation of this because it rearranges all the pages and it compacts this. So this is moved away and it compact. This becomes different page number and so on and so on. And this becomes disorganized. So what I want to do now is see what my options are if I've done this. So I'm going to shrink the database. And again, that's causing fragmentation of that index. And I'm going to just look at it just to continue with it. It's basically 15 megs, so it's shrunk a little. So now I'm going to look at the fragmentation percent in percent. So I'm going to execute this. And notice now that the fragmentation of the index of the object of the database itself has gone from virtually 0 to 99%. So this particular action causes a tremendous amount of fragmentation. And when you have fragmentation, it causes a massive amounts of performance issue. So now the question becomes, should you rebuild the index or reorganize the index? And as you can see by these little values here, it clearly indicates that we should rebuild the index, which means we're going to drop the index that we had on the second table, and we're going to start it all over again, basically. So basically, what we're saying in a nutshell is we're going to take this and just throw it away, and we're going to start again and organizing it from Baker, Barker, and again giving up the proper pointers so it's all nice and organized. That's what we're talking about. So we're going to do that. So we're going to rebuild it, and this is the command: alter index, column name, on table with rebuild go. And remember, this can be done online or offline, and I would have this on a scheduled basis from a job. I'm just doing it here. So we're not selecting reorganize because it doesn't fit this parameter. And now if we look at the fragmentation, since we've thrown that away and rebuilt it, again, it should be 0 because now there is no fragmentation. This index has been reorganized and rebuilt from scratch, and it's all organized according to the data. So that's how you determine if you have fragmentation. And I think that's it. So that's an example of what happens and what options you have when you have index fragmentation. Now, obviously, this is one of the important concepts to have, indexing, and how to resolve it. Now, this is very much the same thing that I do in a production environment, try to determine first if there is any fragmentation and then make that decision on that. Now, every company is always different. As I say, it all depends. But this is a structured way of doing it. I've done it for a couple of clients, and they were extremely happy that their result set was taken about a minute to 20 seconds. And after looking at some analysis, I reduced it to 2 seconds. So that's a wonderful thing. So anyway, so this probably terminates now the last conversation or video I'm going to have about indexing. Again, I've been mentioning that indexing is a very large subject, if you will, but this should give you enough information to learn on your own and move on. So I think I'm going to leave it here because I think I'm approaching 20 minutes or 50 minutes, so that's a good point. So again, this is gives you a good example of how to manage index fragmentation and what it's all about. So I'll leave it here, and my name is Raphael, and this is how to become a production SQL database administrator.